Science Snake. Hello, welcome to my YouTube channel, Science Snake. So today we're looking at chemistry gas laws, specifically Charles' law. So let's do the first problem together. Charles' law is V1 divided by T1 equals V2 divided by T2, in where V stands for volume and T stands for temperature. Number 1. The temperature inside my refrigerator is about 4 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 22 degrees Celsius and a volume of 0.5 liters, what will be the volume of the balloon when it is fully cooled by my refrigerator? If you've seen my other videos, you know the 3 steps: identify the variable, plug, and chug. So the first thing I want to do is identify the variables. We are given 4 degrees Celsius, 22 degrees Celsius, 0.5 liters. Always go back to the word problem you are given and highlight or underline key terms. In this problem, we have the word initially, which is my clue that 22 degrees Celsius is my T1 and 0.5 liters is my V1. Why 1? Because the number 1 refers to the initial or start, and the number 2 usually refers to the final or end point. That makes V2, or my final volume, the unknown. So I went ahead and identified each item. V1 equals 0.5 liters, T1 equals 22 degrees Celsius. However, we must convert that to Kelvin by adding 273 to it. So that gives us 295 Kelvin. V2 is the unknown, and T2 is 4 degrees Celsius plus 273 K, and that gives us 277 Kelvin. I went ahead and wrote everything down again to stay neat and organized. V1 equals 0.5 liters, T1 equals 295 K, V2 is what we are looking for, and T2 equals 277 Kelvin. We identified all variables, so step 2 is you're going to plug it in. Charles' law, V1 divided by T1 equals V2 divided by T2, so I plugged in the values. 0.5 liters divided by 295 K equals V2 divided by 277 Kelvin. I then cross-multiplied and got 277 Kelvin times 0.0017 liters per Kelvin equals V2. I can then cross-cancel those units out, which are the Kelvin, and I end up with liters. So now you plugged, and now you can chug. V2 equals 0.5 liters. So now it's your turn. Go ahead and pause this video and solve problem number 2. Charles' law is V1 divided by T1 equals V2 divided by T2. Don't forget the 3 steps we learned. Identify the variable, plug, and chug. So you're back. The answer is 0.7 liters. If you didn't get the answer, don't get discouraged. It just means you need more practice. So let's do number 3. How hot will a 2.3 liter balloon have to get to expand to a volume of 400 liters? Assume that the initial temperature of the balloon is 25 degrees Celsius. Step 1, identify the variables. So the initial volume is 2.3 liters, followed by the initial temperature of 25 degrees Celsius. However, we must convert that into Kelvin by adding 273. So we get 298 Kelvin, followed by the final volume, which is 400 liters. And T2 is our unknown. Step 2, plug it in. Use Charles' law to plug in all of the values we identified. So you get 2.3 liters divided by 298 Kelvin equals 400 liters divided by T2. What you want to do next is cross-multiply. And you get 2.3 liters times T2 equals 400 liters times 298 Kelvin. Next, 2.3 liters times T2 equals 119,200 liters Kelvin. You then want to isolate the variable, so you divide both sides by 2.3 liters. T2 equals 119,200 liters Kelvin divided by 2.3 liters. We can then get rid of the units liters. We can then grab a calculator for our final step, which is chug. T2 equals 51,826 Kelvin. Quick reminder to always include units in your final answer. That's it for this video. If you enjoyed it, don't forget to subscribe and give it a thumbs up. Thanks for watching.